Welcome to our second Friday video for this week, talking about water level in groundwater in the Tucson area of Arizona. So a lot of my family members live out in the Tucson area, so we used to travel there to visit them almost every year. It's a beautiful area. It is desert, not empty desert like a lot of the Sahara in Africa, but dry, sandy. It looks like a desert. A lot of cactuses, including saguaro, the tall ones. So around Tucson, a lot of people from, say, the upper Midwest, places like where I grew up, Michigan, Illinois, Wisconsin, a lot of those people, as they get older and retire from their jobs, become what we call snowbirds. And they go down to Florida or Arizona in the winters to avoid the long, gray, snowy winters that we have in the upper Midwest. So that is a lot of the development that has happened in the Tucson area in the last 40 years is people buying second homes to spend their winters in. It does get pretty hot in the summers there, but in the winters it's just lovely. Low humidity, perfect temperatures. Gets cool at night, but in the days it's just great. So a lot of people have moved there. There's a lot of development going on. Tucson historically got its water from wells. There's aquifers. It's in a valley that's surrounded basically by mountain ranges. And so rain and snow from those mountains would make its way down and end up underground feeding this aquifer, although a lot of the water in that aquifer has been there for thousands of years. So the aquifer got the bulk of its water during the last ice age. So this is one of those examples of a renewable resource, water, groundwater, but you almost have to treat this one like a non-renewable resource. So when they're modeling groundwater extraction in Tucson, a lot of times they actually use models for oil extraction because it takes so long for this aquifer to recharge naturally that we basically have to treat it like a non-renewable resource. And so one thing that means is what they've had to do is say, listen, more people live here, want to live here. We don't have enough water for them. We can't just have people move in without water. So the state passed a law that said if you want to have new development, you need to guarantee that you have at least 100 years worth of water available to you from some source. Paired with that, they did this large project called the Central Arizona Project. That's a big canal that goes to the Colorado River and pulls water from the Colorado River and brings it to Phoenix and then down to Tucson. So that is how the city of Tucson has basically gotten around its water problem. It was pumping too fast from its aquifer. It was unsustainable. The whole city was actually subsiding. Subsidence is when ground levels decrease, and that can happen if you're pumping a lot of groundwater out. Then that water was helping hold up some stuff and it'll settle a little bit and your ground level will actually drop. So the city of Tucson was sinking a couple feet per year at times. That has largely stopped because they started bringing in this water from the Central Arizona Project, from the Colorado River, and that's how the city of Tucson gets most of its water. So it's not pumping nearly as much anymore. They do still pump some, but there's another law that requires essentially some balance between what you pump and what you recharge. So you can recharge an aquifer. If it's a really slow natural recharge rate, you can bolster that by releasing water into it. So they actually use water from the Colorado River, the CAP water, and some of that they let go into the ground to replenish the aquifer. Often that takes the form of something like watering a golf course or some sort of ag irrigation that a lot of the water makes its way down into the ground and trickles into the aquifer. So here a question, the article was about a lot of new developments in the Tucson area aren't right within Tucson. They're in these, what we'll call exurbs. So there's suburban neighborhoods outside the downtown. Outside of those, you get these kind of wide open spaces, but a lot of people moving into them. And we call those exurbs. So the development in the exurbs of Tucson often are pumping water from the underwater aquifer, and they're doing it in unsustainable ways. You can tell that because they can measure how deep down the groundwater is, and that water level is dropping. In some places, it's dropping several feet per year. So, water's already pretty far down in a lot of places in the desert, 100, 200, 300 feet down, and it's getting further and further away each year, which makes it more and more expensive to pump it up. Other issues about the water quality. But so that's an issue, and we see a lot of that because the state law says you need to replenish the aquifer with roughly the same amount that you are pumping out of it. But here's the problem. You have this big area that is, say, the Tucson area. The city of Tucson may be right here, and there's mountains there, and there's mountains there, and there's mountains there. Also some mountains there. There's a highway going up toward Phoenix. There's a highway going down toward Mexico. But so the city of Tucson is getting most of its water from the CAP, and it's using actually some CAP water to help recharge the aquifer, especially in some ag fields and stuff down here. But people who are setting up pumps here are pulling out a lot of water. And that's where we see these water levels dropping really rapidly. The law says just within this big circle, you need to be recharging the aquifer at roughly the same rate that you pump out of it. Since it's such a big circle, hundreds of square miles within that, you shouldn't be surprised if you have some areas where people are pumping quite rapidly, ground levels going down. They're paying other people to offset that by feeding CAP water into the aquifer, but that's happening down here. And so you're going to get the issues that come with dropping groundwater levels. You're going to have the subsidence, you're going to have water quality issues of what you're pumping, it's going to get more and more expensive. So natural resource economists look at things like, well, what should the appropriate scale be? If we have a law that requires you to offset some activity that has a harm on the environment, where do you offset that? Because what we could do is make little districts, right? And say within this district, if you're depleting the aquifer, you have to replenish it within that district. And you could have these little districts all over the place, right? Then you're going to get a lot less of the disparate heterogeneous effects where you have water levels dropping in some places and stable or maybe even rising in others, dozens of miles away. So if you have smaller districts, that means you're going to have a lot less of that. So why didn't they do that? Well, it's a lot more expensive to do this. So the CAP canal is coming in over here somewhere. It's not going right near there. So you're going to have to actually create a whole new set of pipes to pump that water over to here if you have to recharge it within this smaller district. So it's always a balancing act. We can try to minimize our environmental harms. Economists will often say one thing we should consider is if people have a harm, they should be able to offset it by creating a benefit in some way. But there's always going to be this trade-off. If we force them to have a benefit really geographically close to where the harm is, then it's going to be much more expensive to run that program. On the other hand, if it's a really big area that they're allowed to trade within, if we're talking about environmental amenities, they're almost trading it, right? I'm pumping water as long as you put some recharge into the aquifer. So bigger areas makes it a lot cheaper. There's a lot more gains from trade to be had. We can have big scale and be more efficient about things, but you're more likely to run into these more localized problems where things are happening in different places. So you're seeing environmental amenities not reflecting what they used to be you have degradation in some areas and maybe even improvements in others. So this happens with things like water recharge. It also happens with stuff like um, providing habitat for species. It happens with wetlands. In states, if you fill in or destroy some wetland to make some kind of development, a road, a business, whatever it is, you have to replace it by creating new wetland. Now, sometimes you have to create it on the same physical property, so that's a really small scope for that program. The offset has to be right next to where it used to be. That's a lot more expensive than if you let them say, as long as you create it somewhere within the state. Well, maybe it's really easy to make some new wetland out in West Tennessee where there's a bunch of low-lying areas that are already pretty close to being wetland, right? So it might be a lot cheaper to have a much bigger area you can trade within, but the environmental amenities you're going to get out of the program might look quite a bit different. And it really depends what you're looking at, where the right balance will be. Sometimes we might actually want really big scale. I mean, if we're providing habitat for species, we probably don't want isolated habitats here and there and there if we need the species to be able to have good genetic diversity. It might be better actually to have everyone be able to kind of do their offset in one big centralized really good habitat area. So it depends. It depends on the species and the program. But so that is the natural resource econ, one of the trade-offs economists are thinking about with something like groundwater in the Tucson area. Thanks.